handling lifecycle events, maintaining view state, and persisting data. These are all common challenges on Android that we've dealt with since the beginning. When I started developing applications in 2009, we were dealing with a lot of the same issues that we deal with today. And so what I want to talk about a little bit is clean architecture, what it is, why you should care about it, and then also take a look at the new Android architecture components and how we might be able to use those to improve on an already existing clean app design. Okay, so like I was saying, clean architecture. Well, why should you care? First, I think it would be helpful to talk a little bit, oh, that is pink, isn't it? It'll be helpful to talk a little bit about what we mean by clean architecture. And for me, I think first and foremost, this means having a plan. Before you start writing your code, having an idea of how you might want to lay it out and how you might want to separate things can be a useful tool as you're approaching a new project. Also, I think key in the concept of clean architecture is the idea of having layers to your application and clear separation between your UI versus your logic versus your data. And then finally, once you have these layers and you have a plan, this will allow you to lay out your classes in a cohesive way so that each thing can do one thing and do it well with regards to the single responsibility principle. And so what are the advantages of clean architecture? Well, it allows us to have a certain degree of flexibility with our code base. It makes it easier to evolve and change it over time. And last but definitely not least is it's a benefit when it comes to writing automated tests. And so I feel like clean architecture is really one of those things where we start out with the best laid plans and the best intentions for how we're going to build our application. But what happens is things can quickly start to degrade over time if we don't apply proper maintenance and refactoring. As our timelines get impacted by deadlines and scope creep and things like that, it can be really easy for what started out as the best intentions for a clean architecture to devolve into something else. And so maybe we start out with an idea of what our application should look like, but actually we wind up building something that looks a little bit like this. Or maybe something like this. Or unfortunately, over time, without proper care, your code base could end up looking like this. What we actually want to build is something more like this. Or maybe like this. Or like this. This picture in particular reminds me of an interview I heard on NPR a while ago with an author who was doing a book tour in Japan. And his sort of PR manager went ahead of time to arrange all the travel plans, and including the accommodations. And when he got there, they had a traditional Japanese architecture house that they were staying at. And when he walked in, there was this huge, beautiful open space with almost nothing in it. But then just on one wall was a table with a flower vase with one of the most beautiful bouquets of flowers he's ever seen. And he's just like looking around like, this is incredible, what is this? And he turns to the manager says, this is elegance. So really, when we're applying that principle to software development, elegance is the leaving out any unnecessary complexity so that the true form can shine through. Now, before we get into clean architecture, I want to talk a little bit about, for lack of a better term, what is maybe classic or kind of the default way that a lot of us have been building Android applications for a long time now. And so whether you started off in the early days of Android, Alpha, Beta, Cupcake, or whether you just started picking up Android more recently, chances are your project started the same way. It started with an activity. And so this is kind of the basic construct that we have in Android for building an app. And so what exactly is an activity? Well, to start off, it does a few things, like interacts with the lifecycle. And this is really the contract of how it's going to communicate with the operating system. An activity, by its nature, is also a context which gives us access to things like system services, like the layout manager, location manager, package manager, so on and so forth. Well, an activity by itself doesn't imply any sort of a user interface. So in our example here, let's say we have an edit text and a button located in our activity. And then as applications often want to do, let's say we need to fetch some data from a web service, and then we also might want to cache or persist that data locally. So we had this construct called an async task, which can help you with, as good Android citizens, we don't want to block the UI thread with long-running operations. So we had this thing called an async task to help with that. And then at some point through the history of Android development, along came fragments. And so fragments were rolled out as part of our addition of tablet support for Android as these reusable components that can help us manage chunks of UI for different form factors, orientation changes, that sort of thing. And so while there are a lot of advantages that came with fragments, there was also a good deal of complexity in that now we have not just one, but two life cycles to manage. And then let's not forget that at the other end of this application we're building, we have a real live human being who's interacting with it, and they're doing things like clicking on our buttons and entering text into our edit text. And so we might want to validate that input and make sure that they're entering things that are actually sane, and that we can actually use those inputs to make the application function. And so at the end of the day, what we have here is, I really think, very aptly described as a tasty burrito. And so it's like if you get to the end of the line at Chipotle, and after you've already had your burrito fully built, you say to the cashier, you know what, actually, I don't think I want white rice anymore. Can you switch that to brown rice? Well, they can't exactly just swap one out for the other. They're going to have to build you a whole other burrito from scratch. And so, unfortunately, a lot of times when we need to evolve our applications, that's the situation we were in if we were using the tasty burrito anti-pattern for our architecture. And so what are some of the challenges with this? Well, number one, it's difficult to modify behavior. If you want to change any one of the components in here, chances are you're going to have to change the way everything around it also works. Also, here goes those pesky users again. They want to do something as bold as rotating their device. Well, then this whole thing is going to get torn down and rebuilt, and so you're going to have to manage that state. And then finally, for testing, if you want to test any one of these components in isolation, the same thing kind of goes for changing the behavior, and that is it's going to be so tightly coupled to everything else around it, you're going to wind up having to build up the whole application to test one piece of it. So fortunately, there are alternatives. And so over the past few years, it's great to see that the idea of clean architecture has really risen in popularity in the Android community. And there's a number of different common patterns out there that folks have been experimenting with. Model-View Controller, Model-View Presenter, Model-View-ViewModel. I think the important thing to keep in mind is that these are not new concepts. In fact, they're older than Android itself. And so if you've never read this original series of articles by Martin Fowler, this post is from 2006. You can see in there's a section on Model-View Controller, Model-View Presenter, Humble View, which shares some similarities with view models. And so it's worth noting that these are not new ideas in software development, but rather the challenge for us as Android developers has been in exactly how to apply them to the Android environment and the unique special snowflake that it can be. So let's take a look at another approach for maybe building our sample application that takes a little bit different of a design pattern to maybe be a little bit more flexible, a little bit more maintainable, and a little bit more testable. So once again, we begin with our activity. But this time, instead of starting to stuff things inside of the activity, I think it's useful to think about separating out our logic that doesn't depend on the Android system into its own component. And if we're going to separate our logic out, why not just take the next step and also separate out our data as well? Well, for me, I think, and a lot of people might stop here in their concept, their visualization of what the Android system looks like for an application, but I think it's really helpful to also think of the view as its own component separate from your activity. As we saw before, the activity already has a lot of responsibilities, so thinking of the view as its own thing, whether you want it to be a compound view or a fragment or some kind of custom extension to a layout, thinking of it as its own component I think can be really helpful, and we're going to see why. So now the question becomes, what do we call these things? Well, as we know, there are only two hard problems in computer science, and so you're going to get a lot of different takes on what these components should be named. So for me, I like using the pattern of calling my logic the presenter and then calling my data the model. And naturally, the activity remains the activity, and your view is your view. Now, you could think of your activity and your view as all one thing, and they're definitely both in the UI layer. But for me, I think it's helpful to visualize them as two separate pieces. And so now, our activity is going to forward things like user input and lifecycle events onto our presenter, but then the presenter needs a way to communicate back to the activity. Well, we don't want it holding on to a concrete instance of the activity, because this can introduce some challenges. So we're going to put that activity behind an interface, and maybe we'll call that interface the controller. So now we have a controller and a presenter in there, which a lot of people are probably like, you can't do that, it's MVC or it's MVP, but really, these are just names, right? These are just sort of abstractions for us to be able to reason about and think about how the different pieces of our application talk to each other. So let's put our activity behind this interface that's called a controller. And then maybe to go a little bit deeper on the data portion, let's not just have these concrete models sitting around, but we'll create sort of a vendor or a store or a repository that gives us back models, and that will also manage our connection to our web service and our local storage. You know, it's really great. I was in the back here for Brian's talk before this one. It's really great how many talks we have right now about testing and architecture on Android, because that wasn't always the case. And I think it's really a great sign of the maturity of the community that we've gotten to the point where this is like front and center about what we're thinking about. So, all right, and so now as we start to add back in all the other things we saw in our previous example, we can see that everything gets laid out in a much cleaner, more separated modular fashion. And then on top of that, we can further sort of logically separate these pieces by introducing dependency injection. And this way, nothing has to worry about creating new instances inside itself. They can all just be injected through constructors or fields or however. And now you can imagine how this has a lot of benefits when it comes time to making a change to our application as compared to what we had in the first example. Not least of all, as I mentioned, when it comes to testing, what I really like about using an architecture like this is it allows you to draw a line right down the middle and say, this half of my app cares about Android, and this half does not. And then when we start to introduce our testing tools, it becomes a no-brainer where to use something like Espresso or Roboelectric versus where to use our pure JUnit tests. Okay, and so that brings us to architecture components. I have to say that when architecture components were introduced at Google I/O this year, this is the second most excited I have ever been about an announcement at Google I/O. The first was when Android Studio was announced and we were moving away from Eclipse. Oh, and by the way, I love the honeycomb throwback theme here. Okay, so I'm not going to spend a lot of time on this because there are some great talks out there that have already introduced these components, and they've been out for a few months, so folks have had a chance to read about them and experiment with them. But let's just do a quick recap of what are the different tools we have inside of architecture components. Then we're going to look at how we might apply them to our existing clean application architecture. So lifecycle has a few things inside of it. There's the idea of lifecycle owners, there's the idea of observers, and then you also have events and states. And so this is sort of a simplification of what we had to manage before when it came to the activity and the fragment lifecycle. And so you can see here we have this nice diagram that breaks it down for us, and there are fewer states that we have to be concerned with than when we had to put listeners inside of all of our on-stop, on-start, on-pause, on-resume methods to make sure that our application was doing the right thing at the right time in the life cycle. And so this allows us to do things like query the life cycle, as well as have some implicit awareness of what state we're in. These code samples actually come from the nice example application that is available for the architecture components. And so I'm just going to highlight a few pieces of what you can do. And so, for example, this allows you to query the current state and then perform a certain action only if we're in the started state, which means that your activity is either started or resumed. So life cycles are mostly behind the scenes and sort of are the glue that enable all these other components we have to interact effectively. You can also interact with them directly if you choose to. So the next piece we have is ViewModel. And what ViewModel does is it's a tool that helps you persist your view state through configuration changes and other lifecycle events. And it can also be useful in managing your asynchronous data fetch, which gets that logic out of your activities. You can also share data between UI controllers. There's that word again that we were using there alongside our presenter, but the idea of a UI controller being either an activity or a fragment or a compound view. And then you can still use, now view models don't necessarily lock you into using MVVM architecture. You can use them alongside a presenter if you have more complex logic for your display. But all of this is kind of working towards keeping our activities lean and clean. And another important thing to point out here is the view model should not hold a reference back to the original activity or view context. And so here's the diagram for the life cycle, and you can see the view models persist through all of the changes until your activity is finally finished. And that's when the view model is cleared out of scope. Okay, and so here's an example of how you might use one. And so you can see that when this fragment is first created, we're asking for the view model provider to give us an instance of our view model. Now, the first time this call is made, you're going to get a new one, a fresh instance of the view model, and then subsequent calls made from the same scope are going to give you that same instance back. And then this allows us to subscribe the UI to changes in the view model so that we can then update our interface accordingly. But you might be wondering, okay, so how exactly is this happening when I set up this observable on my view model get products? You know, what is facilitating this? Well, that's where live data comes in. And so live data is this wrapper for our data that allows us to observe changes to it. It works as a bridge between the lifecycle owner and the observer, and is also aware of the current state of the lifecycle owner. So live data can be really valuable in preventing crashes and memory leak that might come from attempting to perform an operation on your UI at the wrong time, say, for example, when it's in the background. And so the way you use live data is really simple. You just wrap your existing models in it, and it gives you that observable interface. Now, the last piece of the architecture components I want to speak to briefly here is Room, which is our SQLite abstraction layer. And this can eliminate a lot of the boilerplate you need to deal with database code. Also gives you compile time validation of your SQL. And finally, it works pretty well with that repository pattern that we already introduced back when we were talking about clean architecture. And so I'm hoping, my hope for Room that this exists now is, I know we're all guilty of abusing shared preferences at one time or another just because we didn't want to deal with writing SQLite. And so the fact that it's a little bit easier now, come on, we've all done it. The fact that it's a little bit easier now will hopefully lead to fewer of those transgressions as we're developing our applications. Okay, and so you can see here that Room works by providing some data access objects that then get you to your entities, which then are exposed to the rest of the architecture. And the way this works is you can literally annotate your models, your data classes, with what the table name is in SQLite, also flagging the primary key. And then you have this nice interface, and you can see here we can set up Room so that it literally returns us the live data instances that we can then take advantage of inside of our view models and subscribe to from our UI. So it's really nice how all these pieces can either be used individually or they can also be used in conjunction for a coherent architecture. You're saying, okay, that's great, but if I don't want to rebuild my app from scratch and I already built it in a clean architecture way, how can I take advantage of these components? So let's come back to our clean architecture example here. So we have our layout with our activity behind our controller interface. We have our compound view that wraps up our edit text and our button. We have our presenter layer, which is responsible for the presentation logic. Then we have our repository, which is vending out our different models and entities that also manages our web connection and our local storage. Well, as a good first step, we can just take advantage of the fact that our activity, we can make it lifecycle aware and actually have it be an owner of a lifecycle, which then will broadcast to the other components inside of the app what its current state is and as it transitions through these different events. And so there's a couple ways to do this. One is you can have it implement the lifecycle activity base class. The other option is if you're already using a different base class, and by the way, that's a temporary thing. That's going to change once we get to V1 of stable API for architecture components. The other option is you can implement the lifecycle owner interface and just do a little bit of manual work there to expose that lifecycle of your activity. Okay, great. So there's a good first step, and we didn't have to make too many changes to our existing app. What can we do next? Well, say we want to use ViewModel here. We could just swap it in for our presenter. So this is one option for how to adopt this component, and puts it on the non-Android side of our architecture, if you remember drawing the line down the middle. So this can be a great move and an easy win. But say you have a lot of logic already built up in your presenter, you might not want to immediately get rid of it. Actually, hold that thought. I'm going to come back to that. There is another option here, which is using a specific type of the view model called the Android view model, which gives you access to the application context. Now, if you really need a context inside of your view model, this is the way to get it, because you obviously don't want to hold on to the activity context, as that's going to be destroyed and recreated at times. But I would caution against using the Android view model, because now we're introducing an Android dependency into the non-Android side of our application, which is going to have implications for testing. So that's my word of caution on that one. Anyway, getting back to if we already have a presenter and we want to adopt a view model without totally swapping out our existing presenter, they can be used side by side. And so we could use the view model as a tool to persist the view state, but then still keep all of our presentation logic in the presenter. This would allow us to also scope the presenter to the life cycle of the activity and not have to worry about persisting that, since the view model will take care of persisting the state through the configuration changes. And then the presenter can do the complex logic of formatting exactly how you want that data to be displayed. So moving a little bit further down the stack, we can also introduce live data, in that our repository can then wrap the models that it's fetching for us in those live data instances, so we get that nice, clean, observable interface. And then finally, we can take room and use that to wrap our storage object or our database, and then make the management of that interaction between the repository and the SQLite just that much cleaner to maintain. And so all in all, you can see here, we didn't have to make a ton of changes to an existing app to start to adopt these components one by one. And you can use any or all of them in whatever combination works best for your application. So where do we go from here? Well, I really think the emergence of clean architecture on Android as a theme and a trend has really been driven by the community. And so in some ways, the introduction of the official architecture components library, I feel like, is a nod to the community, and Google picking up what the community has been putting down for a couple of years now and saying, okay, we're on board with this. We want sort of a reference pattern of best practices for how to lay out an app. It allows you to mix and match components. Like I said, you can use one, any, or all of them inside of your application, which gives us a lot of flexibility. As a final reminder, we are still in preview release. So APIs are subject to change. And the thing I mentioned about having to extend the activity base class or the fragment base class, that's all going to go away eventually as the support libraries pick up official implementations of the stable API in V1. So another interesting point this brings up is, are we at a point of doubling down on fragments as a community? So it's the community who is really driving the idea of clean architecture. It's also the community who has been somewhat moving away from fragments over recent years. And so the fact that we have this new set of tools to make fragments slightly more manageable, could this be the resurgence, the rebirth of using fragments in Android development? Or is the fact that you can develop your own UI library with lifecycle aware components, going to push us even further away from fragments and move us in the direction of using more of these custom solutions that are more view-based and move further away from the fragment based implementations. It'll be interesting to see how that plays out, and just like anything, there's going to be a lot of different interpretations and takes on it, so I think it's a really exciting time to be involved in Android development. Any way you slice it, I think that the future is looking bright for clean architecture on Android. We have architecture components now, we have these clean design patterns, and tools like dependency injection are all valuable assets that can help you make your applications more flexible, more maintainable, and more testable than ever before. Thanks. I would say that talking about, the question is about which component is responsible to make the service calls, meaning the web service, right, over the network. Yeah, so I would say that that should be inside of your repository layer. And so the presenter shouldn't care whether the object is coming back from over the network, whether it's coming from an in-memory cache, whether it's coming from a database. That should all be sort of abstracted away inside of the repository and transparent to the pieces that are going to use that thing when it's finally available. I knew somebody was going to ask me about data binding, and I actually don't have a lot of experience with it firsthand. I've always used, so the question is, how does data binding fit into clean architecture patterns? It's another way to build that interface between your UI layer and your sort of logic layer. You can also use observables that we get through live data. You can also use RxJava. You can have some sort of callback listener interface that you set up in custom role. So there's a lot of examples. That's another way to do the same thing. And so just again, we have all these different choices, and options for how we build these things is really going to depend on your specific use case. It requires a context. So if you have some sort of service or model that actually requires a context to function, how would you use that inside of a view model that shouldn't hold on to a context? Yeah. So well, if it can function based on an application context, you could use the Android view model, which gives you the ability to access the application context. Now, if you need an activity or a view context specifically for that component, you might need to abstract it behind some kind of interface, but you're going to have to do some more TLC to manage that so that that context gets refreshed each time your activity goes through the lifecycle changes. So maybe you would want to build some manager around it that is also lifecycle aware, that can know when the activity goes away and gets recreated, and then can set that new instance. But I would still say that that probably doesn't belong in the view model, just because that's going to be specific to maintaining your UI state. And because it does live longer than all of your activities will, or fragments, then it can be problematic to have that hold on to that reference to the original context. That would be one way to do it, or maybe you could build a sort of a singleton manager around it that kind of helps out with that. Yeah, so the question is, if you have your activity lifecycle events, should the presenter be subscribing to those, or should the activity be broadcasting those to the presenter? And so I think the way that if we're taking advantage of the new lifecycle components, the way that works is the activity is going to broadcast those, and then the presenter is going to pick up on those either through the view model, or it itself can become lifecycle aware, and it's going to receive those. And so just to clarify, in the example that I was illustrating, your activity is your controller. So that's just an interface that we put the activity behind, which becomes really useful during testing, because then you can just have some dummy implementation of that interface that then your presenter gets tested against. But when you're running your real application, I would say it's much more of the activity/controller broadcasting out the events, and then the presenter listening for them, or the view model. How would you persist the presenter? Yeah, so you really, this is a tough choice. You have two options here. You can either scope your presenter to the life cycle of the activity, so it gets destroyed and recreated along with the activity with each rotation. That keeps your presenter a little bit cleaner, in that it doesn't have to worry about maintaining state. But the challenge there is you still need to maintain that state somewhere, which is where, if you use a view model, you could just put the current state in the view model. I mean, I guess the old school way of doing it would be to put it in the bundle. Now, the other way of managing that is you can make your presenter outlive your activity lifecycle events, and persist through all of those until the activity is finished, but then it's basically behaving the same way the ViewModel component is, and so you might as well just use that. No, so the question is whether or not examples are available, like official Google examples for using this with other patterns like MVP. And that I'm not sure about, but I would say to your second point about whether or not you're forced to use MVVM, I would say definitely not. The fact that the components are mix and match and you can use each one individually gives us the flexibility to use any architecture that makes us happy. So there are some examples available in the Android blueprints that use like MVP or not necessarily following the MVVM pattern. Okay, thanks so much. Enjoy the rest of the event.